So earlier, oh, I'm sorry. So these are the answers to the problems. And the only thing that I would want to say is that for these triangles here, we could use one letter for the angle measure because there's no ambiguity. If we say angle J, it's very clear what angle J is. If we say angle B, it's very clear what angle B is. There's only one angle using B as the vertex. However, if we're over here, we need to use 3 letters to specify some of these angles, right? For angle A and D, we could use just one letter because there's only one angle using that vertex. However, for angle ACB, we have to use 3 letters because if we say angle C, we don't know if we're talking about angle ACB or angle BCD. Right? So because 2 angles use the vertex C, we need to use 3 letters to specify the angle. So same thing goes on over here, and same thing goes on over here and over here. Another thing that I would want to say is that when we are identifying all the corresponding congruent parts, we also want to specify for these 2 triangles that BC is congruent with BC. And although that seems trivial and something that we don't need to specify, it's going to be necessary when we're proving that 2 triangles are congruent. Because to prove that 2 triangles are congruent, they have to have corresponding sides congruent, all of them, including BC is congruent with BC, and also all corresponding angles congruent. Then we could say triangle ABC is congruent with triangle BCD. Right, and that's about it. Down here we had to figure out the value of x and y, and then we have our next section, which is proofs of triangles being congruent. So 2 triangles are congruent if and only if their corresponding parts are congruent. Corresponding parts include corresponding angles and corresponding sides. The phrase if and only if means that both the conditional and converse are true. So yeah, if and only if means it goes one way, it also goes the other way. 2 triangles are congruent if their corresponding parts are congruent. It also goes the other way. Triangles' corresponding parts are congruent if if the 2 triangles are congruent. Right? So we can go both ways. And so a way that we can shorten this, corresponding parts of congruent triangles are congruent, is we could say CPCTC. And that's going to be one of our reasons for our statement here that 2 triangles are congruent. Okay, so let's go ahead and start here our proof with our given, of course. So I'm going to put a number 1 here and say AB is congruent with CB, and AD is congruent with CD. Okay, and then angle BAD is congruent with angle BCD, and then also BD bisects angle ABC. So number 1 is given. Oh no, I hope I have enough paper here. Okay, so we're given that AB is congruent with CB, so I can go ahead and draw a little line here and there. We're given that AD is congruent with CD, so AD is congruent with CD. Notice I'm using a different mark. And then we have BAD is congruent with BCD, so this angle here is congruent with that angle there. And then we're given that BD bisects angle ABC. So BD bisects ABC. All right. So the next statement that we could say is that angle CBD is congruent with angle ABD. And the reason for that is the definition of angle bisector. And the definition of an angle bisector, if you're not aware, is that the line bisects an angle if it divides the angle into 2 congruent angles. Right? So here we go. Okay, so then what else do we need? We need the third angles theorem, which states that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles of the triangle are also congruent. And that's what we have so far. we have that two angles of a triangle are congruent with two angles of another triangle. Right? So that means the third angles are congruent. So for 3, I'm going to say angle BCD is congruent with angle BDA. And that's going to be the third angles theorem. So now we have all of the angles and all of the parts of the triangle congruent. Oh, I'm sorry. We still don't have BD is congruent with BD. See, I told you that we're going to need that. So we have that this side is congruent with that side. We have this side's congruent with that side. But we don't have that this third side of the triangle is congruent to itself. So let's do that. Let's do side BD is congruent with side BD. And that is going to, the reason for that is going to be reflexive. Remember that reflexive property that I told you about? That we didn't need when we were doing algebraic proofs? Well, now we need it. And you can see why. It's because we need to prove all the parts of this triangle are congruent with all the parts of that triangle. And to do that, you have to say that this side is congruent with itself. So now we have all the sides and we have all the angles congruent. So lastly, we can go to the proof here, which is triangle ABD congruent triangle CBD. And then the reason for that is going to be this long statement, or we could say CP CTC. And we're done. So once we're finished with this, we're going to be asked on the next page to complete a couple of other proofs here. And notice they're all triangle congruent with triangle. And how do we prove that two triangles are congruent? All of the sides need to be congruent, corresponding sides, and also all the corresponding angles need to be congruent. And we have one tool so far we can use is the third angles theorem. So if we can get two angles of the triangle congruent, then we could say the third one is also congruent. So that should help you out when you're proving these statements here.